Hi there, algebra students. In this video, we're really going to talk about comparing linear, exponential, and quadratic models. Chapter 10 has been all about quadratics, but we saw in Chapter 8 exponential functions, and earlier on in Algebra A, you saw linear functions. So Section 10.8 is comparing those three different functions by the looks of their graph, by how ordered pairs or tables of values look. We're going to kind of skip over writing equations for these things right now. We're just going to kind of compare, and hopefully by the end of this video be able to recognize the difference between a linear function, exponential function, and quadratic function. There are a couple ways that you can do this. So this first method, if we're trying to choose whether this table of values or sets of ordered pairs represents a linear function, exponential function, or quadratic function, the first way to do it is to use a graph and tell whether they represent a linear function, which would be a line, an exponential function, which would be a curve, or a quadratic function, which would be a parabola. And if you go back to the first slide, it shows you what these graphs look like. So linear is a line, exponential is going to be a curve, quadratic is going to be a parabola. So the first and the most basic way to tell which is to plot the points and on a graph and see what the graph looks like. The second method does not use a graph. The second method is strictly looking at the ordered pairs or the table of values and deciding linear, exponential, or quadratic. So in a linear function, the differences of successive y values are all equal. That really means that consecutive or successive y values are going to increase or decrease by the same amount. So from one y value to the next, to the next, to the next, so on and so forth, it's going up by the same amount or down by the same amount. An exponential function, the ratios of successive y values are all equal. So ratios meaning when we divide, the division, the quotients all come out to be equal. Another way to look at this is that consecutive y values are being multiplied by the same number. So from one y value to the next, to the next, to the next, so on, they're all multiplied by the same number. And then a quadratic function, you could look for what's called the second differences. So you would subtract the consecutive y values, and then you would take those differences and subtract them again, and that would give you the second difference. All of those are going to be equal. What's a more obvious way of identifying quadratic function is you're going to see a mirrored pattern in the table with the y values because it's a parabola. So the y values may decrease and then go back up like a parabola does. So you may see repeats or a mirrored pattern with y values. Like I said, we're going to kind of skip over writing the actual functions. So once we decide, we're going to skip over writing. In this video, we're just going to talk about deciding which represents linear, exponential, or quadratic. But here's what you could do to write the actual models. Here's an example of a linear function. So if you were to plot these points on a graph, it would make a line. If you notice, it's showing you that all the differences 5 minus 2, 8 minus 5, 11 minus 8 are all 3. What that really means is it's increasing by 3 every consecutive y value. So that's an example of a linear function. Here's an example of an exponential function. So they're showing you that the ratios are all equal. 2 divided by 1 is 2. 1 divided by a half is 2. 1 half divided by 1/4, or 0.5 divided by 0.25 is also 2. So the ratios are all equivalent to 2. Another way to look at it is all these y values from one to the other, consecutive y values, are being multiplied by 2. 0.25 times 2 is 0.5. 0.5 times 2 is 1. 1 times 2 is 2. So if you see that the y values are being multiplied by the same number over and over again, then it's exponential. And then here's an example of quadratic. Here's the first and second differences, like I talked about earlier. So 5 minus 2 is 3, 2 minus 1 is 1, 1 minus 2 is -1, 2 minus 5, -3. And then they subtracted these again. 3 minus 1 is 2, 1 minus -1 is 2, -1 minus -3 is 2, so the second differences are equal. But even more obvious than that, you see this mirrored image of y values. So this is kind of where our axis of symmetry would be. And then we have y values of 2 on each side. And then we also have y values of 5 on each side of this axis of symmetry. So you see this mirrored pattern here with quadratic functions. So that should give you some help on identifying and telling whether equations represent linear, exponential, or quadratic models, specifically looking at tables of values or lists of ordered pairs for the functions when you're not necessarily given the actual equation for the function. So just to repeat, you can either graph them and decide linear, exponential, or quadratic, or you can look at the table of values and decide using the table of values or the ordered pairs whether they represent a linear, exponential, or a quadratic function.